Welcome to today's Energy Central Power Session entitled, The 21st Century Grid is Here. Do you have 21st century construction management? Before we begin, I'd like to take a moment to thank our sponsor, Locust View, for making today's event possible. Now, without further ado, I'm happy to turn the floor over to today's moderator, Mike Smith, to kick things off. Mike, welcome to the event. You have the floor.
All right. Thank you, PJ, and thanks everyone for joining us today. We've got a great panel put together, and we're going to be talking about some real interesting things, particularly as you take a step back and look at the direction of the utility industry and how there's some tools and some processes that are really going to help utilities and those teams both in the field and in the back office be more successful with some of the challenges they're confronting in what I like to call this new energy landscape. So we're going to hear from our panelists in just a minute, but I had a few thoughts to share with you first about some of the things that we see happening in that landscape. So PJ, maybe next slide. So we're just going to pull a few industry data points to kind of share where we are as an industry, and then look at diving into that in terms of how work is getting done, particularly in the construction space, with all the new things from DERs to grid scale renewables to some of the transmission challenges that we're seeing in the space. So we're going to dive into that and get a better feel for this new energy landscape, but more importantly, how folks are working in that landscape. So PJ, next slide, please. So I don't think that we need to spend a lot of time talking about DERs or distributed energy resources. I think we all can see that they're not only here, but they're growing, and in some cases that growth is accelerating. You can see the figures here that it's becoming a very large market, and it's also contributing to the gigawatts of generation that are going to be needed to meet the growth that we're seeing in load across the country, where you have things for like electrification efforts, EV efforts, and of course AI and data centers. So are DERs the answer to that growth? I think it's maybe part of the answer, but I think more importantly, there's some implications about how the grid needs to be operated and maintained as that growth continues. Next slide, PJ. So again, I alluded to just a moment ago about looking at things from that back office to the field. The field is where a lot of this stuff happens. And again, this is a growth area, particularly as that new energy landscape evolves and you start to see things where, can we have real-time updates? Are we doing things where we're reporting accurately? Because there's some real reliability and safety issues tied to all of that work. So not only is it a growing space, it's a space where there's some new tools that are going to enable utilities to, again, improve performance, improve safety, and improve reliability in real to near real time in many cases. Next slide, please. And our final data point before we dive into this with our panel is just that the Edison Electric Institute has shared some industry data. And one data point that I thought was interesting was $100 billion a year in T&D infrastructure upgrades over the coming year. That's a lot of money. I was actually on the phone with the assistant general manager of a very large municipal utility yesterday, and their budget for infrastructure just on the grid itself over the next year is $1.4 billion. So there's a lot of growth here. There's a lot of activity. And of course, how do you manage that more effectively? And again, in that real to near real time environment that can have implications around performance, reliability, and safety. So with those thoughts, we're going to kind of dive into this with our panel. And what we're going to do is I'm going to introduce each panelist as we go, and we have an opening question for each one of them. I'll add as we dive into this that we've had a lot of preparation for this. We've had multiple phone calls, and I've really learned a lot from our panelists, and I think you all will today as well. So we're going to go alphabetical by first name. So we're going to start off with Chris Nichols. I'm going to tell you a little bit about Chris, then we're going to ask Chris the opening question. So Chris Nichols is the GIS manager at Black Hills Energy with over 20 years of experience in GIS across various industries, including 11 years in electric and gas utilities, water and natural resources, and government. He has diverse expertise encompassing Esri, Small World, and QGIS platforms, as well as data integrity, field data collection, as-builting, and design processes. His skill set has enabled him to lead several major upgrade teams, successfully modernizing the GIS tools and processes within the organizations where he's worked. Notably, he has spearheaded the implementation of mobile mapping tools, streamlining field operations, and enhancing data accuracy. He holds a BS from St. Lawrence University and MS degree from South Dakota School of Mines. So, Chris, thank you for joining us. I do want to ask you an opening question here. And in my opening remarks, I commented about DERs and how that footprint is growing. When we spoke, it is growing in the Black Hills service territory as well. So what are you seeing as the challenges for the folks that are responsible for doing the work, and by the way, keeping the data accurate and up to date as that work gets done? So that encompasses everything from the field to the back offices. And kind of the background noise, or maybe the corollary question is, how does all this impact keeping that connectivity model current, with the implication being, if you don't do this in a real-time manner, again, there's those safety and performance issues. So what are some of the things you all are seeing as DER footprint grows, and as you all are continuing to get the work done to keep the grid performing?
Yeah, we see a lot of challenges, and they vary across our footprint. The Black Hills electric footprint spans South Dakota, Wyoming, Colorado. So if you have any familiarity with geopolitical sciences in any way, you know there's a very different way of thinking across each of those different states, and where the importance is from the legislature, as well as what the PUC considers acceptable costs for customers when it comes to implementing DER in those areas. So we see our biggest growth in Colorado. Probably doesn't come as any sort of surprise there. We've got differences in challenges with residential DER versus large commercial DER. When it comes to the customer side, rooftop solar, we've got a couple of folks who have installed even some residential wind production for themselves. A lot of that work is done outside of Black Hills with third-party vendors who are putting those facilities in and tying into the network. Typically, our workflow, we will see all of this stuff designed, whether it's new construction, replacement, et cetera, within the company. If they do it in the GIS, we see it. It's available on all of our maps, down to reliability. When it comes to DER, we don't have that insight necessarily. Usually we're finding out about how and where and when these DER facilities are coming onto the system through other databases on our network. We've got a team that works very closely with those renewable resources and our customers that want to install those, and they've got their own database. So we've actually put a lot of work into figuring out how we can consume that, represent it in GIS, represent it downstream to our partner systems. And a lot of that has actually come to fruition pretty recently with some improvements we've made to our workflows. But then when we come to commercial DER, the challenges are a little different in that we usually know something's going in. We've got internal plans for a collector substation, or there's some other information that's going around. People know, there's a buzz around some of these bigger DER projects going on. So we know that they're coming. We can be better prepared for them. But our challenge comes down to, okay, what's the configuration? What assets are going in? Does Black Hills own those at the end of the day, or are they still owned by a third party? And what are we responsible for, specifically in a reliability standpoint, that we need to provide to our live maps for reliability to handle that in their system? And then we can even go down into challenges around, who's responsible for maintenance. As far as reliability, we're learning more and more that, our generation side of the company wants to know that everything's in good working order, even if we don't own it. So how do we represent those assets in our maps so that they can be properly accounted for and inspected?
Right. Yeah, I think that's the challenge. It's a little bit of Wild West when you start looking at consumer-owned renewables, for sure. Have you seen any implications around the connectivity model as all these new assets are connecting to the grid? How is that impacting keeping that current and up to date? So when linemen are out there doing work, what's connected, what's not, et cetera. And again, there's performance issues there, but perhaps more importantly is the safety issues.
Yeah, absolutely. Safety is obviously our number one industry concern. We went through a major system upgrade back in 2022 to bring on board more tools to be able to create the DER models and provide insight into that information for our users, both in the field and in the office. as far as that goes, we just actually, since we last spoke just a couple weeks ago, we implemented a new workflow where we are now putting in some of these DER and other metering pieces well before any construction ever begins. They're on the map. You know, we've got our unique IDs tied to those, and as things come online, whether it's rooftop or commercial, those information points are feeding into our spatial nexus, if you will, of the customer information as it's tied to the network so that we can feed it downstream.
Okay, great. Yeah, and I think that's a good point for what we see happening in the industry, just because the stuff's growing so fast, and trying to get ahead of it, I think, is half the fight. So that's good on you all at Black Hills. We're going to move on to our next panelist, Danny Petrecka. Danny, who some of you may know, leads the business development efforts at Locust View, focusing on expanding digital as-builting to the electric industry and telecom markets. He has over 20 years of experience in the utility and telecom space, having worked with Miner & Miner, Telvent, and Schneider Electric, and has vast knowledge in that planning, design, construction, GIS, ADMS workflow throughout the world. So, Danny, thank you for joining us. And much like we did with Chris, I'm going to ask you an opening question to get the ball rolling with you. One of the things that's interesting when we do these panels is we often find that our utility panelists have a very deep knowledge about what's going on in their utility. The value of having someone from the solution provider community like yourself is your knowledge is pretty deep, but you can maybe point to a lot of different data points that you see with any number of customers that you speak with. So the nature of my question is going to kind of leverage that experience with you. So when you're working with your customers, where or what challenges do you and your Locust View colleagues see in the workflows that are not optimized? And what we're looking for here is, what are some of those implications, particularly with some of these massive grid mod efforts that we see underway in the US utility industry? So like I mentioned earlier, I was speaking with that assistant GM of a large municipal utility, and he was very upfront about, we're spending $1.4 billion in infrastructure just this coming year. So when those workflows are not optimized, what are some of the implications for what's happening there? So can you maybe just comment on some of the things you're seeing out in the utility space on that?
Sure. Thanks, Mike, and thanks everybody for being here. Yeah, the implications are really the thing that we want to raise awareness of. And like you said, there's massive spend on grid mod. Let's just put the finger quotes up there, grid mod. That includes digitization or modernization of lots of IT and OT systems, but also a lot of construction. And I think these legacy IT systems are well known, and the OT systems are well known, and they get upgraded, they get implemented. But what we see more and more is that utilities tend to neglect the processes and workflows that feed the mission critical data into these systems. So the implication is you're going to have less optimized CapEx spend, and you're going to have a lower ROI on the promise of your new shiny ADMS or your Flizzr. It's not going to give you the payback you want. And I think one of the workflows that gets neglected is that construction as built-in workflow. If you think about these IT/OT systems, they are like a brand new modern high performance sports car, right? They're optimized, they're modern, they're fast, they're fun to drive, and they give you a lot of ROI, right? But you can't put 85 octane gas in that thing. The engine is eventually going to gunk up. It's going to degrade your performance. Your VVO VVC ain't going to work, not in your car, but in your ADMS. Your Flizzr is not going to work, giving you payback on your SADI K fee. And these critical systems have a payback that really requires that data from the field, which was feeding data into these systems to be good. And I'll give you one analogy. You talked about a company, a utility you spoke to recently. I spoke to one last year. They had just spun up their brand new ADMS system. It was running beautifully. Leading up to it, they had spent a lot of time and money cleaning up their GIS data to feed that network model, that asset data into their ADMS. We were talking to them 2 years after they spun up their ADMS, and they said, you know what? Half of our substations are no longer analysis ready. That means half of their substations they could not run into these advanced functions on anymore, and it's because they kept putting bad gas into their ADMS. They hadn't fixed the continuous pump of data into their GIS to feed their ADMS, so it was gunking up the engine. Maybe they need some Slick 50 in there or something. I'm terrible with analogies, so apologize.
That's pretty good. That's good.
But that's what we see is they focus the ROI on the functions, but you got to look at the gas, the old garbage in, garbage out analogy.
Right, and that's important. I think the collective years of experience on our panel here today is well over 100 years. I know for me it's 35 years, and it's so interesting that you're making that point. I can remember as a young market analyst 35 years ago studying electric utility GIS. We used to call AM/FM. Some of you may remember that. You'd go to the events and you'd see the really slick demos and everything, and then you talk to the utility folks. At the end of it, it's all about data. It's like data, data, data. And I think as an industry, we've obviously come a long way, and there's some really interesting things happening on that front. But it's a good reminder that you got to do that basic blocking and tackling and really pay attention to that. So point duly noted. I think we're going to revisit some of that as we get a little deeper into today's session. So thank you, Danny. We're going to move on to Jenny Burgess now. Jenny is the manager of GIS services at Dominion Energy. She's been there for 24 years, where she has worked in just about everything they do there. So design, safety and training, emergency preparedness, customer service, operating center, scheduling, business support, storerooms, and now GIS services. Sounds like they're training you to be the CEO there, Jenny. Her breadth of distribution experience enables her to help with user awareness of GIS applications. So Jenny, I want to talk to you about some of the things we talked about in our prep for today's session, about utilities undergoing this large digital transformation effort. And one of the things that, reflecting on some of the things that both Chris and Danny commented on is, digital transformation is cool. It's big. It's going to change the way the utility operates. But there's some very basic blocking and tackling types of things that need to happen. So one of the things I wanted to ask you about is how have you been successful, and maybe what are some lessons learned around getting those field crews on board with the new technology? This is something I've looked at in other industries. I've spent most of my time in utilities, and I think we've come a long way from where, maybe as recently as 10 years ago, you still had data that was handwritten notes on a map book in a truck, to someone else had their own spreadsheet, to maybe 2 or 3 different legacy systems of asset management and GIS. So what are some of the things you all are doing to make sure that those field crews are on board with some of this new technology that, again, enables the performance and safety, particularly in these areas where there's a lot of construction happening as grid mod and this new energy landscape advances?
Well, I think the first thing that we learned or realized is that our people didn't become linemen because they wanted to sit in their trucks and enter data on their computers all day.
Right.
And though we implemented our first mobile as-built solution about 15 years ago. It's all tabular, very clunky. They hadn't had computers in the trucks before, and they were really resistant, and it wasn't easy. And so the quality of the data that we were getting wasn't great. There was no mechanism for any spatial changes. So if they put something in a different location, the best we could hope for is that they told someone in the office who then passed that along. So, over time, I think some of that's gotten easier. So 15 years ago, we had a much older workforce, and the folks that we have now, I think, are, a lot more comfortable with computers. They're a lot more computer literate. Software is better. It's simpler. It's easier to learn how to use. One of the things I always say when we're talking about Locust View is I think it's a little bit like Amazon. You don't necessarily have to be taught how to use it. A few kind of things to give you an idea of how it works, and you're good to go. And but I think we have to make sure that our people understand the value of doing what we're asking them to do. And more importantly, it just has to be easy to do it. Easy, and having something that you can do on an iPad or a phone rather than on a clunky laptop that you're pulling in and out of the truck, or you're having to sit in the vehicle and do it. I mean, I think all of those things can make it easier. And one of the things that we've been excited about as we move forward with our digital as-built plans kind of into the future is the opportunity to scan barcodes or QR codes to get some of that data that's even more challenging to get accurately, such as manufacturer serial numbers. I mean, if we're living in the past, a serial number was the thing that somebody manually entered in the field. It came to the GIS team on a PDF, and then we manually entered it into the GIS. So there were two opportunities to fat finger something that isn't very easy to get accurately.
Yeah, and I think we're gonna revisit that barcoding a little bit, just a little bit, for the whole panel. One thing I'm curious about is the devices used in the field. You'd mentioned maybe an iPhone or an iPad, I think you'd said, as opposed to maybe those hardened laptop types of things. What are most of the people in the field using, and what's the life expectancy of a device in the field? Because I would imagine it's not the same as someone in an office, and how do you all hedge against that?
We're transitioning from those hardened laptops to iPads. So we're in transition, which means right now everyone has one of each. And I've said this for years. We've been using those hardened laptops, I don't know, close to 20 years, maybe 15, and they cost 5 times as much as a laptop. So you can break a lot of iPads.
Okay. Okay.
Before you break even, So okay. So I think we feel pretty good about that. And in iOS devices, I think back in the day with phones, you'd buy a phone and every couple of years you had to get a new one. And with iOS devices, at some point you realize like you're like 6 generations behind, and maybe you should get a new phone because they do cool stuff now. Yeah. So we haven't been implemented long with them for field users, but I feel really optimistic about how that's going to go. And all you have to do is just buy a case. That's a little tough.
And Jenny, what we found actually is in our history is if you give them something that's hardened, they're going to test out how hardened it is, and they're expensive to replace. We found that when you give them the tablets, they're a little more delicate, and they really like them, so they tend to take much better care of them in the field.
Nice.
Yeah, good. All right, very good. Thank you, Jenny. And Lance, we're going to jump over to you now. And for our audience, I'll tell them a little something about your background, and then we'll dive into some of the things you're doing there at MDU. Lance is the Director of Field Operations, Technology, and Process Improvement at MDU Resources. His areas of responsibility include work and asset management, GIS, mobility, operations systems, and R&D there at MDU. He has over 30 years of experience in the utility industry and as well as energy industry, and resides in Boise, Idaho, beautiful Boise. So Lance, I'm going to jump over now and ask you about some of the things that we had talked about in the past. One of the things that you all have spent a lot of time and effort on was creating a catalog of parts in your Maximo asset management system. So can you talk about how your digital construction management system, in this case LocusView, interfaces with that system, and why is this important, and what's the impact of being able to access this data within your digital construction management or DCM system?
Yeah, so just as way of background, we've been going through a digital transformation at MDU. We're 1 million gas and about 170,000 electric customers over 8 states. We started the project aligning all of our procedures across 8 states and doing all of our maintenance work, and then we transitioned into construction, and we just went live on the gas side of the business with construction 6 months ago, and we're in the process of implementing the electric side of the business now for the digital construction management process. So that just kind of gives you a framework of where we're at. We were able to take our inventory system and translate data out of our inventory system into Maximo. So we had to build an integration to have that information flow into Maximo. We built a catalog inside of Maximo of the parts that we had on the gas side of the business, and then matched that up with the LocusView mobile system. And we were able to push work orders out to LocusView with a bill of materials. So depending on how much time somebody wants to put a work order together, they can write down detail, all the parts listed that are going to go on a job. have them go out to Locust View. The parts catalog is in Locust View, so we have a match there. What it enables is, first off, being able to leverage having that parts list in the field. And by the way, we have iPads as well, so we have a ruggedized case on the iPads. They're dedicated to construction management, so we don't use them for multi-purposes. They're pretty much with a kit, stay with a kit. So I think there's a nice protective kit with the rest of the GPS software. So they're able to go out in the field, barcode scan the plastic, and that matches up with the part number, and then able to document everything that was installed in the field in terms of the inventory and the parts. So once they complete the work order, it can come back into Maximo, and then Maximo then integrates back to our system for our inventory on the accounting side, and we're able to relieve inventory. So that really enables us to more accurately capture the assets that we're installing in the field and then bring those back, and it streamlines the process of inventory. You can imagine, we were kind of a hodgepodge of different systems across the 8 states when we went into this project, but mostly on paper. So you're out there filling out paperwork, part numbers, anything that has to do with tracking and traceability, lot numbers, a lot of opportunity for writing that down wrong. And then, it comes back in, somebody's got to manually enter that data into the system, and there's an opportunity for failure there as well. So I think it's really enabled us to capture accurate information in the field and bring it back in, and then relieving the inventory in an automated way saves time too, so it makes it more efficient.
That's actually pretty impressive, and especially the integrations, but also as you were building this, that sounds very labor intensive. Can you give us an idea of the scope of what it takes to get to the point where you have that inventory in place? And I imagine there's a lot of manual work going into that initially. What does that look like?
Yeah, so it was actually a 2-year process where we worked with policy and procedure to standardize our parts. So if you could imagine, across 8 states, everybody, and we grew through acquisition. So we have 4 main brands. So Cascade Natural Gas is in Washington and Oregon, Intermountain Gas is in Idaho, and MDU is in the Montana Dakota utility area. So Montana, North Dakota, South Dakota, a little bit of Minnesota, Wyoming, and including Great Plains, which is the Minnesota piece. So they all have their own, parts and using. So we went through a process of standardizing those and getting agreement across the company on what parts we're going to use. And so moving to that, basically moving the inventory down, getting the standardization there. So that was very helpful to bring that in. And so you don't have to manage as many part numbers. So then taking those part numbers and creating the catalog from there. Some of the challenges certainly are using up some of the old inventory. So we have to still accommodate for that. So if there's inventory that's being used that's not part of the standard, somebody's out there doing that, we got to have those parts cataloged. We got to have them out to Locust View. We got to bring them back and relieve them from inventory. So it sounded good to have them standardized, but it's a lot of money to just scrap, some of the older parts that were being used. So we're basically using them up. And so that was one of the challenges for sure, is just being able to accommodate the older parts, but nice knowing that we're moving toward a standardization there.
Good. Yeah, boy, there was probably a lot of challenges as you described growing by acquisition. Everyone probably had a different asset management system, maybe GIS, or at least different standards on how they were using those. So someone had to take that on. So sounds like you had a big part of that too. So good on you for getting through that. So 2 of our 3 utility panelists have mentioned that they're using barcoding. So I want to visit that just for a minute. Jenny, I think you all are barcoding there in Virginia, correct?
Not yet.
Not yet.
We're doing some tests, but
Okay.
we're hoping to implement that next year.
Okay. I want to explore this just a little bit, and actually this is something that we had talked about in our prep for today. Danny, I want to start with you around the barcoding. What are you seeing and hearing from your customers? I mean, obviously, I can see it saves time, it improves accuracy because there's less manual entry. What are some of the benefits? Is it strictly is there an ROI piece to this? Is it a streamlined of operations? Are there metrics around that where you can see what that improvement looks like? what are you seeing and hearing as it relates to barcoding when you're talking with all your customers in their construction management processes?
It's extremely simple. I'm going to tie together what both Lance and Jenny talked about. It makes data capture easy in the field. They don't want to be scribes in the field, the electric linemen. So the thing that barcode scanning does is it stitches together what Lance did, which is you digitize a parts catalog or a material list or a compatible unit library. You digitize that. There's a lot of rich data in there that drives asset data that is eventually going to get to GIS. How do you leverage that, maintain it, send it to the field, but then allow the field people to work in a very easy way and speak a language they speak in, which is just, it's materials, it's transformer KVA, it's 45-foot class 2 pole. They don't talk about CUID number 1252. So what the barcoding does, it allows you to say, okay, I'm going to install this transformer. Let me barcode scan that. It's going to go, hey, I know from this SCAPE barcode scan, I have these attributes. Let me match that to the design that sent this compatible unit over to me that has those attributes, and say, hey, you know what? You're installing the right thing. Or say, you know what? This doesn't match with your design. And then what that does is it allows the valid data to get passed on to the GIS and the ADMS on closeout. But the people in the field, they don't have to be scribes. They don't have to write down a serial number or 45 attributes like windings and the impedance for a transformer that they don't care about, but ADMS really cares about. And you got to make it as easy as when they're scanning a box of screws at Home Depot or a carton of milk at the grocery store. Scan it. It knows how to charge me, but I didn't have to worry about writing anything down.
Again, Danny, what percent of your customers and utilities that you work with have barcoding up and running, at least for a significant part of what they do, maybe not completely?
Yeah, and you're exposing one of the gaps here, and I'm going to tell you why. So all of our gas customers, in one way or another, they have the benefit of the ASTM barcode scanning standard for their plastic assets. So Lance, on the gas side, I'm sure you guys are leveraging that for as-builting on the gas side. The electric side, very few. We're piloting it through the SCAPE program because there is no standard. There's no marking standard for electric assets yet. So we're working with everybody you see here, plus IEEE and EPRI, to build a standard called SCATE, and that stands for Supply Chain Asset Traceability for Energy, that all utilities, and all of these are already doing this, can call their manufacturers and say, hey, transform your manufacturer X, here's a specification for you to give me deliver my transformers with a SCATE ID on it so that I can leverage it in supply chain, inventory, design, as-builting, and asset registry. So it's still very much in the pilot phase on the electric side, but there's a spec available today that utilities can use to send to their manufacturers to leverage today. And I think that's along the lines of what Jenny says they're going to be piloting soon.
Is there a governing body for SCATE?
Yeah, it's IEEE.
Okay, all right, good. You may have said that.
We've worked with IEEE, EPRI, and 30 utilities and manufacturers to help develop this standard. It's not a standard yet, it's a specification. The standard process takes a little more time, but there's stuff people can use today in utilities to take advantage of this.
Okay, and there is another arm of SCATE too that includes steel tracking and traceability. So there's another movement in the industry to get barcoding on steel. So that is also in the works. And again, like Danny said, I think as an industry, we have to start pushing manufacturers for following a standard. So I know the standard, the database, the modeling, and everything is more mature, I think, for the steel than it is on electric. But I think we're close. I know Alicia at Locust View drove getting that standardization on plastic, and she's also really spearheading, I believe, Danny, as well on the SCATE effort for both steel. The other piece I wanted to mention too is on assemblies for the gas business. A good example would be a gas riser going up to on a service line. It's made up of components of some plastic pipes, some steel parts, a valve. So we're also trying to get manufacturers of assemblies to barcode the entire assembly. So when you scan the barcode, you're getting an inventory and tracking and traceability for that entire assembly. So that's somewhat of a gap, I would say. On the plastic side, we can scan everything plastic, but when it gets into an assembly, we can scan, then we end up getting a pop-up of maybe 4 choices for a riser would be a good example. They pick the right riser, they know the part number. It's an extra step, but I just wanted to note that that's another area that's working towards standardization, is on the assembly side.
Good, yeah, and these are not trivial efforts. There's a lot of moving parts, literally and figuratively. So good on you all for taking the leadership in that. Chris, I want to come back to you as we talk about what's going on in the field. And I noticed from your bio that you've done some work in the mobile space, actually quite a lot of work there. So you're working with the field folks a lot. So in the context of what we're talking about here today, particularly around some of these construction processes, how have you and your team been able to improve field data collection, and how has this improved efficiency and effectiveness of your team? So maybe this is a before and after story. This is how we used to do it, but we implemented technologies A, B, and C, maybe Locust View somewhere in the mix, and this is how we do it now, and this is what it looks like, particularly if there's any metrics around it. So what does that look like in terms of how you've been able to improve that field data collection from all those folks out in the field doing all that good work?
Yeah, it's definitely a before and after, and where we're headed to kind of story. So,
okay.
Black has been GPSing assets in the field since the 1990s. We've got a very high accuracy data set and connected model. They started back with Geo3 units and the full-on keyboards, and of course you're opening yourself to typos, fat fingering, getting inaccurate information through those methods. So we further advanced in the early 2000s, 2010s using GeoXHs, and it's on screen, it's got cameras and rangefinders, and getting a little more high accuracy in how we're collecting things, more information that we can pull back to the field to verify the information. And then in the 2020 timeframe, our gas side of the industry made the jump onto Locust View. We're doing really successful as-builting with that process. At that time, we were doing a GIS upgrade, but as we came out of that upgrade, we started noticing a lot of the legacy systems we were using on our field applications were being deprecated. There was no successor platforms coming out for it, such as Windows Mobile. That was shut down, and we were still using some of the old tools with that. But we wanted to find something more modern, something that was going to keep up with the way systems were upgrading. So we did a pilot with Locust View, and Danny and team came out, and we took our legacy process and translated it into Locust View and did a pilot for 3 or 4 months with the system side by side, our legacy and Locust View, and we're able to prove out the concept that we can continue to do work the way we've been doing with our existing workflows, which worked really well with our business processes at the time. So by the end of 2023, we threw a curveball at Locust View, and we wanted a GPS technology that hadn't yet been set up, and they powered through. They got us all set up with that technology. So we're using RTX receivers in the field today. So we're saving our teams over 100 hours a month in post-processing. We don't have to bring data back, pull information back from base stations, and post-process the data ourselves. It comes back to us ready to go into our network. Aside from that, we've got the addition of Locust View Cloud, and we've got the web maps that they provide, so we can see the live progress our teams are making, and we can track things. We have a safety aspect where we know where our teams have been. If there's any loss of communication with them, and somebody's wondering where they are, we say, well, they were here last, they were headed to this location. We can kind of zero in on that. But then we also have the technical debt side of it, where these legacy systems that are being deprecated, we can retire those. We can get onto a more modern system, and one that's maintained by Locust View. We don't have to have that technical ability in-house to maintain it.
Great. Okay. Yeah, and when you talk about saving over 100 hours a month, I mean, that's very real. And those crews and those individuals, they're spending time on things that are more valuable. And I think that's a big win there. So yeah, thank you for that. By the way, you started, so 2020 was the gas side, and then was 23 you were doing the electric side? Okay, all right. I wanted to make sure I was catching that right. So Jenny, we're hearing a lot about as-built processes and how there's some improvements in that, and a lot of that is streamlining and more efficiency and leveraging that technology. Several of you have used the term fat fingering, which I think is really funny, but I've been guilty of that myself, and I'm sure a lot of that goes on with people trying to put in data in the field. So what are some of the business drivers that led you all to improve those as-built processes? In other words, there's probably an established paradigm in how your organization was doing that. New technology comes along, and it's not just a function of, hey, let's automate a manual process, let's make it better. I'm sure that's part of the secret sauce in terms of how you move forward. So can you speak a little bit to what that looks like in terms of those business drivers? The technology is really cool, but what are the folks at the director and VP and C-suite level saying, yeah, technology is cool, but these are the business drivers that we need to meet?
Well, we've talked a lot about the quality of the data being important, and I think I'll just take a moment to talk about why. So when we went from paper maps to a GIS 25 years ago, we were going from a place where we were using that map just as a map, right? Just to know where our facilities were. And you knew it was potentially 6 months out of date because you got new map packages in the interoffice mail periodically. And when we originally digitized all of that and built a GIS, the only real difference is that we now had electronic maps that sort of did the same thing. But over time, we integrated it with more and more systems. And with some of the grid modernization things, smart grid, automation, Flisser, things that kind of don't work if your data's not right and can potentially become dangerous if your data's not right.
Right.
We're feeding our NMS, we're feeding our outage management system, we're feeding ADMS, and the need for the data to be right has gone from nice to have to imperative. And we talk about what we might like to do to clean that data up. We're piloting some imagery capture things that can involve a number of different things that you can do with imagery, but to include the opportunity to clean up the quality of our GIS data. But there's no point in cleaning up the GIS data if your as-built process is going to break it slowly but surely every single day. And I think Danny told a story, somebody told a story a few minutes ago about that very thing. And for us, I keep saying if you make it easy, it helps. But the other thing is having some sort of a plan for storms, because we're okay at as-builting on a bluebird day, right, and really, really bad at knowing where we put the material that we took in a storm. And we've talked about implementing with some streamlined forms to make that easy in a different way. So I think the drivers were about we're changing software, right? All the things that we implemented years ago are becoming obsolete. That there's better technology out there. We're replacing our work management suite, and it just kind of opens up the opportunity to say, okay, what can we do better? And so so that's been super helpful. So it's a lot of different things, and it all just ties into the things that we've been talking about the whole time.
Yeah, and you brought up outages and storms, which I think is really interesting because the needs for timely and accurate data is arguably much more acute during those times, particularly coming out of that restoration period. You want to make sure you have all the data right. Have you seen ways that process has improved? Because a lot of that's what we might call short cycle construction, as opposed to the long cycle of putting in a new 20-mile stretch of transmission line or whatever. How have some of these tools helped you all as you come out of that outage and restoration phase? Are you finding that streamlined process is still holding up in that storm setting or the gray sky days? and particularly coming out of that. So what are your findings there?
Well, because of the fact that have a whole lot of software implementations up in the air at the same time, our implementation has been a phased one. So for outages, we haven't yet implemented. But I think it's the difference between knowing that you need a pole to go out and replace a pole that's broken, going into the storeroom, handing them a piece of paper with the project number on it so that they can issue that pole to your job so we know where it went, versus being able to scan it. The transformer is probably a better example. To be able to scan that barcode, open the job because it's on your iOS device, scan it, and it's done. I mean, it's a huge difference. So
right.
the slowdown there, I mean, the vast majority of the material that we use in a storm, we just charge to a generic storm number. So every bit of that is material that went somewhere and we don't know where. So if we have a recall and we're trying to use manufacturer and serial number, or if we have a pole inspection program and we think we've got a creosote pole, but we really don't because we had a storm and replaced 800 poles. We're wasting time inspecting things we don't need to inspect. So I think we've got off track a little bit.
No, I'm glad you brought that up, but I want to tie it back to the whole discussion around skate and barcode scanning. Again, barcode scanning for supply chain inventory and blue sky as-builting makes a ton of sense. But yeah, think about how your beautiful data that you migrated for ADMS, you cleaned it up, and now you have a digital process for blue sky as-builting, keeping your data good. Storm comes through and pokes holes through your entire data set, right? Imagine if you could improve that by 10, 20% by saying, okay, give your mutual crews and your own crews, thousands of them, a very easy to use application where once they're in the fog of restoration, they're not going to write down asset attributes and serial numbers. What if they could just go barcode scan, barcode scan, barcode scan, and move off, and capture data with a quick GPS shot? And even if you can improve the need to go back out in the field and recapture your storm data by 10, 20%, that's a huge amount of savings right there. And then you have equipment coming from across the country. This transformer might not be the same impedance or polarity that I need in my service territory. That barcode scan could catch that and say, hey, wrong transformer, you got to use something different. But again, you can't get in the way of the restoration. Every second, every minute counts. So it's that balance. It's not only does it have to be very easy to use for blue sky, it has to be dead easy for storm restoration, or it just gets in the way and utilities won't risk that.
Right. So what we're talking about, some process improvements, and Lance, I want to jump back over to you. One of the things we talked about in our run up to today's session was that you all have improved processes for getting data from a new installation into your GIS in under 72 hours, whereas in the past, this may have taken as long as 6 months. So can you maybe walk us through that quantum leap that you all have experienced, and just what did that look like from a process standpoint, and maybe share a little bit of the business impact on that as well?
Yeah, you bet. Yeah, so I think going to a digital construction management process and driving work orders out of a central, maximum work and asset system was the starting point. And I think that we went through that process, the mobile solution being Locus View, pushing the work orders out to Locus View. When we capture that data, we're able to capture high accuracy data. We talked about the barcode scanning component, getting the parts right, documenting it in the field. Obviously the big game changer is being able to translate and load that data from Locus View into our GIS system directly. So that translation happens almost a nightly batch process is the minimum. So you get the data out, you get it back into your GIS. We're putting it in a staging database. And then we have a process that runs to copy it into our production database, and we keep the lifecycle status under construction. So it needs to get touched by the GIS editor team. But in the meantime, the big advantage that we have is that we can, I'll call it raw Locus View data. That's probably the best term I could use. We can have a layer in our mapping system that people can turn on and see that raw data. So that's that's a huge advantage of the field because you know, at one point in time I was over our safety management system. When we kicked that process off, we went around to all 36 offices and asked all of our employees what some of our biggest risks are, and one of them was just inaccurate and untimely maps, because they have to make real-time decisions in the field in emergency situations, and they need to have good information. So we worked real hard, and this was part of that solution to be able to implement it. So being able to see that data, you know, 2-day-old data, probably be the oldest data that they would see now. Even, you know, one of the things we did transition to as part of this implementation as well is we have a GIS-based design tool that we integrate with our Maximo system to create work orders that go out. And, you know, everybody was excited about being able to show designs in the GIS, but the reason they wanted to do that was, you know, to know there's something in the works. So if it does take 6 months to map it, at least they know there's a design there. Well, this kind of neutralizes the need for that, you know, because you can see the data coming in, you know, in pretty much real time. So it just increases decision making. And then from that point, the other efficiency gain we get is on the GIS editing team. You know, they were working off of scanned paper, comes in, they have to manually map it, they have to manually enter all the attributes in. We're able to translate the data into the GIS data model, and so it becomes a different function at that point for the editor. You have to get, you know, a few steps to get it into the network and get the life status changed, deal with spatial accuracy issues. One of the things that we're landing on is the source of truth is the data coming, the high accuracy data, GPS coming into our GIS system is now the source of truth. We're not going to move a service line to fit a bad, you know, spatially accurate or mismapped main line, for example. If it shows 5 feet off, well, we're going to move that main up 5 feet. So there is a little bit of a different editing function to make your GIS spatially, even more spatially accurate. We spent a decade improving our spatial accuracy in our GIS system through either, you know, conflation activity or heads-up digitizing, using aerial imagery in preparation for being able to do something like this. So that most of our GIS is in pretty good shape spatially wise. You know, I think we're within plus or minus 10 or 15 feet across the service territory, which is nice. I think that's a challenging place to get to as well. But so yeah, so I think it increases our efficiencies, getting it to the map, and we have a safer operating system, being able to see more real-time information coming from the field GIS.
You said safety, and that's an active word I want to jump in on. Yeah. So Lance, you almost described exactly what one of our other customers at Puget Sound Energy does. Is they do exactly what you're talking. They do the raw locus view prelim data that comes in real time to view through their GIS for awareness and productivity, but more importantly for safety. But then there's a parallel workflow that says, here, that preliminary data is here, and I know if I dig here, I'm going to encounter it, but it's still going to go through a QA/QC workflow to make it that future system of record data. But the second thing is Maria Ilak at Puget Sound Energy, she said exactly what you said. They made the decision that they're going to treat GPS data as the truth, quote, but it might not always be pretty. They know they're going to have some maybe not so pretty maps, but you know, this thing is here because I have a high accuracy GPS asset location for it.
That's a challenge. I know a lot of GIS people are very, you know, it's near and dear to their heart to have a map that looks pretty.
Oh yeah, yeah. Well, I chaired a panel like this at AGA 2 years ago. We're going to AGA in a couple of weeks, and there was a whole panel about the GIS people saying, "How you're ruining my maps? How do we deal with this?" And there's lots of workarounds. I mean, some people do what you did and move it and say just deal with the ugliness. Some people keep it where it is and they keep the metadata there. It's part of a change management process, that's for sure.
Right. Good stuff. And you know, it's funny. I can remember mid 90s. We use terms like relative accuracy versus absolute accuracy. You know, is the pole on this side of the intersection versus exactly where the heck is that pole? So that was a discussion that went on for many years. I'm sure a lot of you have experienced a lot of that. We do have a question from the audience, and Jenny, I'm going to start with you. Are you comfortable sharing which work management systems you are moving to?
So for many years, we have used the CGI ARM suite. and we still are. We are actively moving to the SAP suite.
Okay.
So I guess it's EAM and FSM.
Okay. Great. And there's some recurring themes coming up here, and I want to revisit those. But while we're talking about work and asset management, I was going to ask if each of our utility panels could share one lesson learned around integration. That's something that has always been, I'll say at best, difficult historically. I think it's getting a lot better as data standards have evolved. But can maybe each of you share one lesson learned as you've had to do some of these integrations, which frankly can be pretty massive in scale and scope. So who wants to go first?
I can touch on it. I think that one lesson learned is, when you're pushing as much data as you are out to a mobile solution and getting that data back, is just having the ability to manage the integration through configuration tools. So obviously when Locust View first started out, they built their product for the trench in mind. It was already said earlier that it doesn't take a rocket scientist to figure out how to use the tool in the field. It's made for the person in the trench. And we and Locust View made a commitment to improve upon their integration framework, and we partnered with Locust View to build out tools to manage that integration better. So I think there's opportunity around that, and I think that is a challenging part of getting the data to and from a mobile solution, is just being able to manage things when things change. So if your data model changes on one side, or something changes on another side, or your GIS changes, all those things have to be managed. So having tools available to you to be able to configure that and manage it, I'll call it self-service, is an important aspect.
Good one.
And
Chris, how about you?
I think as far as integrations go, one of the key things I think I've seen over the years is understanding the full expanse of what all the touch points are in the integration you're trying to do. This comes from both sides, being on the project side and trying to find all those touch points, but also being on the side where another team's doing a project and they didn't know that GIS was involved in some way, and they start implementing changes that impact us negatively. So I mean, really doing deep dives into, okay, here's one touch point, but who else touches that point, and how is it important to them? And is the change or integration, whether it's new or something being adjusted from what already exists, going to impact them in some way? And then how do we adjust that, work with them to find that better solution at the end?
So it could be that it's not just purely the technology or the technical side, but that change management piece as well,
yeah.
which sometimes overlooked. So yeah, that's an important part of that. Thank you.
The other thing, Mike, with integrations that I find is that sometimes utilities are busy keeping the lights on and keeping people safe, is they tend to throw whatever apps they have lying around in the garage as part of these other legacy systems at a really hard problem, and they feel like they've digitally transformed things. But like my friend Bill Meehan from Esri likes to say, there's digital transition and there's digital transformation. We talk to a lot of utilities about, hey, tell us about your as-built-in workflow. Oh yeah, we have a digital workflow already. I said, well, show me. And they show me a file full of PDFs. Well, that's digital paper, but how useful is that in optimizing your process? And they go, well, not really. I said, well, the key to making that useful is the integrations. Like Lance said, integrations coming in on the front end from the work and design of materials, and integrations on the back end to update those systems of record seamlessly. You can't just say, oh, instead of handing you a piece of paper, now I hand you a PDF and we've digitally transformed. No, you're still punching things in manually. Those integrations, and integrations used to be a bad word. It used to be like, oh, integrations, complicated, expensive. Right. The technology is so great today that it really minimizes the spend, especially when you get into the upgrade cycle, which used to be the big hurdle for cost of ownership.
Right. And Jenny, I want to ask you a similar question, because I know you all are right in the middle of all this with many of your systems. So what are some of the lessons that you all have learned or maybe are learning as you go through this?
Well, one of the things that I was thinking about with integrations, so our GIS feeds our OMS, and that integration's been in place for 25 years. And so without that integration, we don't know which customers report to which transformers report to which devices, so we don't know who's out. And over the years, I mean, 25 years is a long time for it to be in place. In the beginning, you've got all the people that were on the teams building it out and figuring out how it should work, and they all really thoroughly understand that integration, why it's the way it is, how it works. And then people retire and people change jobs. And I think by now we're at a place where there are probably a couple of people around that really thoroughly understand that integration. And again, not just the what, but the why. And so one of the zillion things that we're doing is replacing our outage management system. And so with that in mind, I actually have 5 people on my team on helping to develop the business requirements to try and make sure that when we rebuild that integration and make modifications to it, because technology is different now, and a purchased brand new OMS can do a lot of things that an old homegrown OMS cannot, that we, in hopes that we are thoroughly understanding what we've got. And I'm trying also to make a point to choose people that I don't think are going to leave the company or retire anytime soon.
There you go. There you go. Yeah. Again, it's not always just a technology. It's a people and process thing as well, and that kind of leaps out at us at times. Yeah, we are moving along here. There's one area that we haven't touched on yet before I get to some of the closing stuff that we want to make sure we do. And Danny, I'm going to ask you about this. I'm out here in Northern California, and as I'm sure a lot of you know, things like fire mitigation is a big issue here. And one of the answers to that that some utilities are participating in is undergrounding a lot of their infrastructure. So I'm going to ask you, Danny, initially, but please, if our other panelists can chime in on this as well. What are some of the things that you're seeing and hearing from your customers around the challenges of undergrounding, particularly as related to as-built and related design and construction projects and processes? Because it is different when all that stuff's underground. So what are you seeing there in terms of those challenges and maybe a few lessons learned?
I'm glad you asked that, because as we were talking about the GIS data accuracy thing, I said that this ties into undergrounding. So the first piece is a lot of the feedback we get from electric utilities is, accuracy for as-builting isn't so important because it's all overhead. I can just drive around, and if it's not on this pole, I look down the street, it's on that pole, it's fine. Not with undergrounding. Undergrounding, you're almost becoming like a gas utility. More and more of your infrastructure is being undergrounded. So that need for accurate location, but also accurate asset information is important, because once you throw that last shovel of dirt on the trench, I don't know, was that 4-aught we put down there? Well, I can't look on the pole anymore. It's down there, and where is it? The other thing is these undergrounding programs that MDU is doing, that Dominion's doing, that Black Hills is doing, you're all doing it. I mean, the father of them all is PG&E doing their 10,000 miles of undergrounding. It is a ton of construction. There's tons of money out there. There's tons of stimulus to get it done. There's so much to build, but the feedback we're getting is we can't just throw more bodies at it to get it done faster. They need to do more with less. And doing more with less is what a digital system like a DCM system can do around streamlining work orders going out, streamlining the design, streamlining the capture of the data. And it's all about optimizing that CapEx spend on these massive infrastructure projects. And the other side of it is the massive amount of contractors that are used to perform this undergrounding. I mean, PG&E can't use their crews to do 10,000 miles of undergrounding. There are huge contractor forces doing this, which facilitates the need to monitor and track the oversight of these contractors executing these projects to avoid ballooning overspend. I mean, we had one customer we were doing a pilot with. They had a $1 million undergrounding project, and a year later it came back and they got an invoice for $2 million because in that 8 months it took them to do the $1 million project, they had a lot of adders, and the utility didn't know until the job was done. What they need is sort of a real-time view of, hey, there's some adders going on, we had to blast through rock, or we got pulled off for some other labor. So they needed that to avoid the ballooning costs. But it's all about accuracy of the data. It's going underground, so you need to capture it at the birth of the asset, which is important. And Chris up at Black Hills, you know, they have their traditional as-builting workflow is to go out after construction and capture the data, capture the GPS locations. But they did pilot, and they brought on a new person who was actually an underground trench inspector that I believe, Chris, you can chime in, I'd love to hear from you. They piloted this to take locust view and capture the data during construction, which, you know, it's going to be buried, so let's capture this data now rather than after the fact. Chris, maybe you could talk a little bit how that worked out for you guys.
Yeah, that individual's still in the field. You know, she's going through with locust view, capturing those trench locations. She was doing her inspections, and that all feeds back into us. So, you know, if the project takes 6 months, and then by the time we find out about it, get the paperwork, it's been done, covered up, sodded over for a couple of months, and we can't see any markings of where that was. We have the real-time collection of that open trench that we can put it. It comes to us, and we just load it up into the map, and we know where those facilities run, and they feed down to the field and whoever else needs access to that. So it's been very effective, and it's helped our underground view immensely.
Good. That's a great example of something that's happening in very real time, especially here in Northern California, to Danny's point. There's, as we think about undergrounding and some of the other things we've talked about, and we have another question from the audience we're going to get to in just a minute. You can see me scribbling down some notes here. There's some recurring themes here. Obviously, safety, that's probably number one, but also we're seeing things around efficiency, accuracy, and data integration. I would again, I want to open this up to our utility panelists, and what is capturing a lot of the mind share there with your senior leadership at your utility when you start talking about using some of these new design and engineering and as-built tools like a locust view, and particularly how that integrates and interfaces with some of the other folks. These recurring themes we're hearing on today's session, what are you hearing from the executive suite in terms of, hey, we know all this work's going on, but here's what really is grabbing our interest. I'm sure safety is a big part of that mix, but what are some of the things you're hearing from the executive suite on a lot of this great work that you all are doing? Open that up to our utility panelists.
Well, one thing that comes to mind that I think is appealing to them is making it easy for the field users and streamlining how many things they have to use, how many applications they have to use in the field. Mm-hmm. So yeah, so in addition to the data quality, I mean, I think we've been at a place where everybody's got a computer and everything's a different application, and it makes it clunky and slow.
Right. So both the efficiency and the accuracy there. What about, are you hearing things around data? Hey, we've made massive investments in everything from smart grid to automation in the field. But are there questions around the ROI of all this data? Hey, what can we do to get better ROI with all this data, particularly that in the field?
Yeah, I think especially for territory, we're seeing a lot of interest around the information that's being collected coming in as far as wildfire mitigation. To touch back on that subject, there's a lot of interest in that going on right now. There's a lot of projects in flight, both on the mitigation side as well as future plans, PSPS type stuff that's in the works. And where should we be doing certain shutoffs? Where do we need to put new equipment to do shutoffs, and make sure that we're taking that to the next level, and we're collecting all that information through these same tools.
Good. Yeah, Lance, it looked like you were about to jump in.
Yeah, the executive team is definitely asking about ROI, doing more with less. I think when you have an integrated solution, one of the big pieces of our business case was accurately capturing data at the source and integrating it to the relevant system. So you're reducing touch points through the whole life cycle process. Obviously, you know, like you said earlier, safety and all the things we've been talking about are an important part of the business case, but there is, you know, there's a piece of that too where, you know, you have opportunities throughout the life cycle. And if you just focus on construction, you know, there's a lot of different areas that you are able to reduce those touch points, and that's reduce labor, but ultimately able to do more efficiently. So, you know, I think there's continuous questions. I was in a meeting this week with our CIO. They're continually asking that. I think some of the challenges around some of those realizing the ROI is you've got to make, you know, you've got to make commitment changes, partnering with the business doing their part. So sometimes there's process change involved. Sometimes it's impact to, you know, different positions throughout the company where roles may change. We had to take about 6 months towards the tail end of the gas implementation to take a hard look at roles and responsibilities across the service territory because things change in a digital world, right? So you've got people that were dedicated to scanning. You got people that were dedicated to doing data entry and inventory and data entry, you know, from paper into the back office systems and you know, working with spreadsheets and various different systems. I think it was mentioned as well. I mean, in our business case, we also have centralizing our systems. So one system of record, you know, is an important part of the business case as well. So one asset management system that collects all the data, you're able to report, get better, you know, information from your system. Whereas before we had scattered systems across the 8 states, it takes more resources from an IT perspective to support a larger stack. And if you can streamline it, it does make it more efficient. So definitely the executive team is looking for that. And you also build that into your rate cases too. So when you do rate cases, you have to justify the money you spend. And part of our justification, you know, states are asking us, what is the ROI? So it's an important component.
And I'll tie an executive buy-in thing to the work we did with Jenny at Dominion. The workflow we're talking about here is inherently complicated and doesn't have a natural owner. You've got design people and engineering, you've got the GIS people, you've got the work and asset management people. What we found is awareness of this problem and there's a potential solution for it was key when Jenny and I first started talking. But for her to get buy-in, and Jenny, I'll defer to you on this, for her to get buy-in, it's not like you just go to one person and get approval. It's like you had to go to a VP who was over enterprise work and asset management, which has one set of goals. You have to go to the VP who's over graphic work design and engineering, and you have to go to the VP over data and assets in GIS to say, okay, this is really going to help all of our systems, but while each 3 of you might have different KPIs, let's all come together and agree that there's ownership amongst you and there's going to be benefit across the all 3 teams. I mean, Jenny, I don't know if you're going to tie into that.
Yeah, I think the executive team landed on me being the owner as a GIS of Locust View, largely because we had a gap and I found the solution. But what I've come to realize as we've worked through it is I actually think it's the right place because yes, the people that are actually going to use the Locust View application, you know, 1,200 people are not in the GIS group and actually report to a different vice president than we do. But we're the first people that appreciate getting that right data and making sure that if we're seeing things that aren't right, that, you know, we're reaching out and doing training and ensuring that it's the way it should be. And the more I've thought about it, the more I think that it makes a whole lot of sense for the GIS business team to be the owner of the digital as-built solution, not just for us, but probably for a lot of others as well.
Well, good.
Yeah,
Sorry, go ahead.
Okay, I'm just going to add on to it. You know, our executive team actually made a decision a year ago for most of the time that we've had Locust View, it's been, you know, within the GIS purview in support of those downstream users. And about a year ago, they did a reorganization and moved it into our IT perspective as part of utility systems group. So all of those individuals that were on the GIS team supporting the application are now in IT. doing the same function they were always doing, and GIS still kind of drives the development and growth and application side of it. But we're feeding those into that support team from an IT perspective, which is where those software dollars live, so that we can properly allocate those, and we're not trying to budget them from a business side when the software is held elsewhere.
Yeah, again, another example of the technology is great, but there's also that people, process, and change management side of things, which are often the difference between success and failure. We do have a question from the audience that I want to ask the panel, and please jump in because I'm not sure who's going to be best suited to answer this one. How does this data collection activity and tool work with the DERs? So earlier in the session, we talked about DERs and how that's changing the way the grid operates and how it has to be maintained and requiring a whole new set of skills and construction life cycles, et cetera. How are you all seeing what we're talking about here today, particularly around as-built and streamlining these processes with the integration? Where does the DERs fit into that mix? And I think there's probably several different answers around that.
I can start, and I think there's a bit of a paradigm, because everything we're talking about today relates to, from our perspective, assets that utilities are designing, constructing, and owning. So if DER for utility falls under that, if it's their own DER attached to their system, it makes complete sense to digitally as-built those using a DCM solution. I think some of the design on the front end and the ownership is a little different when it comes down to the DERs. But if it's residential, if it's behind the meter, then yeah, that poses, like Chris said earlier when he kicked off, we want to know who's doing this, where they're putting it, and what the capacity is. There is a behind the meter aspect of a bit of a blind spot. But again, if you have contractors that are doing your ahead of the meter stuff as well as the behind the meter stuff, there's an opportunity to capture that through a DCM workflow.
Good.
Yeah, I think the legacy of software has kind of allowed us to pull that collection into our existing workflows, and we didn't have to do a lot of change for it. Just identifying that this is now DER versus our typical construction data collection aspect. So we can go out, we can collect all of those poles or those windmills, the boundaries of the solar farms, any of that information through this tool that we want to have, that whether we built it or not is important to have in our maps.
Yeah, it's tricky when you have all the different owners involved, of course. We're getting close to the end. I have a kind of a closing question that I love to ask, and I'm going to ask you this alphabetically as like we did at the beginning. I think we all have a lot of experience. We've touched on that, how experienced or how old we are. But when you look over time and how GIS has evolved and the related systems, particularly around construction, we've come a long way. But I'm always interested in having each of our panelists look into their crystal ball and maybe project, what is this going to look like maybe 3 years from now? So when you think about GIS data, as-built processes, overall improvements in this space, again, from the field to the back office, is there maybe one thing, maybe it's 2 or 3 things, but is there maybe one thing you look at, in 3 years, we're going to have this solved, or in 3 years, we're going to be able to do A, B, and C because of this? So again, I'm going to go through this alphabetically. Chris, I'm going to start with you and maybe share what you're seeing in your crystal ball.
Yeah, a couple of the things that I've seen, recently as well as within the last couple of years is, obviously the growth of AI, and that's, a whole other topic in and of itself. But I've seen some really cool demos around, being on a construction site, taking your phone and video recording all the construction work and the placement of the assets, and it's actually creating, the visuals, the mapping aspect of all of that without you having to stand there, take GPS coordinates, or you take the camera, you zoom into the plate or barcode or whatever might be on the asset, and it's collecting that information and attributing it the way that you want it in the data. Just through magic, technology, and having that model already built when you bring it back to the office, and all you did was walk through the site and record it. That's really got me excited as some process improvement there. But then I also recently read about something that National Grid published, a story that they're working with a group that's taking GPR and electromagnetic measurements along the ground and being able to create high accuracy maps of the underground, and especially in areas where they may not have good information on what's down there, or there may be other utilities that they're next to and they want to be able to isolate their assets from those other utilities, and be able to create a good, useful map that your crews can then follow to do whatever maintenance they need to do in that area.
Okay, good. Yeah, I could see walking around with your phone or a digital camera and just capturing all that data real quickly and tying it in real quickly as well. Danny, how about you? What are you seeing and hoping to see 3 years from today?
Yeah, it's my crystal ball says that the momentum that you already see of the modernization of these systems that's already started, it's going to accelerate. I mean, utilities, earmuffs, guys, they tend to move pretty slowly, but I think a combination of new workforce, new leadership, new CIOs, new innovation, new technology, and new ways of thinking are going to accelerate this. And I think it will be done in a practical way. I think there's a lot, again, Chris said the 2-letter word AI. It is a game changer. What will it do? Everything, nothing, scary things, very important things, but I think it could be a game changer when you couple that with innovations in how a sensor or sensor-based technology can take what seems like a very brute force barcode scan and turn it into take a picture, and it does everything for you. Think about that, how that can improve everything. I mean, I've seen technology out there where it's fly a low-flying drone, and it does ortho imagery, it does a LiDAR point cloud, and it maps that with high-accuracy GPS, and you get sort of a trench model. Very good, but I think there are leaps in how do you take that and make it usable. And that's what I mean about practical. There's a lot of wearables and a lot of fun-looking stuff out there. I think that the eye candy of that will wash out, and you'll get to the really practical uses of it.
Yeah, I think particularly some of the examples you cite when you start applying AI and building those models where you're looking at those images and making decisions very quickly, I think is kind of an interesting and exciting part of that. Jenny, how about you? What are you seeing there at Dominion 3 years from now?
Well, I think that you're all about to learn that I'm probably not a visionary, but I think what I really look forward to seeing 3 years from now is skate barcodes being totally prevalent on serialized equipment in the electric industry. We don't even have to ask for it or make it a contractual requirement because they're just doing it. And all of the tumultuousness associated with changing all of our systems at the same time is behind us. We're operating steady state and just making those little tweaks that you do to make things a little bit easier and a little bit better. And everything doesn't feel quite so hard.
I think that's a great vision, actually. I think if most utilities were able to achieve that, they will really have accomplished something. Lance, how about you? Bring us home.
Well, for those of you playing, buzzword bingo, I better mention digital twin. I just was thinking about that. There's a lot of things we could bring up. AI is a big part of it. I was just going to mention that I think there's an opportunity around that with GIS and having real-time accurate information, feeding the GIS system. You can get, I think, as we move forward with more electronic processes for capturing data, whether it be leaks, whether it be movement on the system. I mean, you can. There's opportunity to leverage satellite imagery and other things that can create an opportunity for a real-time model that could identify risk faster, and using, I think, AI and risk analysis on your GIS system, and improving that whole process of being able to identify risks faster in order to do something about them. I think the traditional models are lagging a little bit, so I think there is opportunity around that.
Great.
Just a little
Well, good
tiny
stuff.
crystal
Good
ball
stuff.
focused on one little spot.
Well, no, that these are all, I think, directionally where our industry wants and needs to go. They may seem small, but I think in total, there's some really interesting and exciting stuff. And again, this group, we've all been in the industry for a really long time, and I think we do see the rate of change accelerating. And there's a lot of good stuff coming out of that. And some of it is just that, again, that basic blocking and tackling around data. Some of it's the exciting new stuff around AI or digital twins. So it's a good time to be in our industry. So I want to thank our audience for hanging in there with us and participating. I obviously want to thank our panelists. This has been great, and taking the time to prepare for this and participate in this. We really appreciate that. And of course, we want to thank Locust View for supporting this session today. And I think I want to hand it back over to our PJ with Energy Central.
Thank you, Mike. And I agree, this is an awesome time to be in our industry. Fantastic presentation. Thank you, panel. And also, of course, to Locust View for making this event possible. For our audience, look for an email from us coming up with a link to the replay and also a quick survey to give us your feedback. We'd love to continue to provide quality content, and your feedback helps make that possible. From everyone here at Energy Central, thank you for joining. We look forward to seeing you on another PowerSession coming up soon. And this does conclude today's presentation. Have a great day, everyone.